CIDR notation is the shorthand every network engineer uses to describe both an address and its network size in one compact expression. Take 192.168.1.10/24. That trailing /24 is doing real work, telling routers exactly how many leading bits identify the network. CIDR stands for classless interdomain routing, and it replaced the old rigid classful system where addresses were forced into fixed A, B, and C buckets. The slash number is simply a count of how many leading bits make up the network prefix. Everything before the slash is network, everything after belongs to hosts. The slash number maps directly to a subnet mask. /24 becomes 255.255.255.0, /16 becomes 255.255.0.0, and /30 becomes 255.255.255.252. Every 1 bit in the mask corresponds to a prefix bit, and every 0 bit corresponds to a host bit. Think of the 32-bit address as a line with a movable boundary. Slide the boundary to position 24, and you get 24 network bits with 8 host bits remaining. Slide it to 16, and 16 host bits remain. Slide it to 30, and only 2 host bits survive, a tiny sliver at the end. Usable hosts follow the formula 2 to the power of host bits, minus 2. So /30 with 2 host bits gives 2 squared minus 2, which is 2 usable hosts. /24 with 8 host bits gives 256 minus 2, which is 254 hosts. /16 with 16 host bits gives a whopping 65,534 usable hosts. We subtract 2 because 2 addresses in every subnet are reserved. The very first address, with all host bits set to 0, is the network identifier itself. The very last address, with all host bits set to 1, is the broadcast address used to shout a message to every host on the subnet at once. Memorize this quick reference and you'll decode any CIDR block on site. /30 gives a mask of 255.255.255.252 with 4 total addresses and 2 usable hosts. /24 gives 255.255.255.0 with 256 total, and 254 usable. /16 gives 255.255.0.0 with 65,536 total, and 65,534 usable hosts. We've covered the theory, how IP addresses and subnet masks carve networks into usable host ranges. Now it's time to take that math and put it directly into a Linux shell, where every formula becomes a real command you can run. First stop, the IP command. We'll inspect our local interface addresses and confirm what the system actually believes about our own network. No assumptions, just whatever Linux reports back to us. Next, we'll pull up the routing table. This is where the kernel tells us which networks it knows about and exactly how it plans to reach them. A direct map of the local routing reality. Then comes the trick. We'll pipe an address into awk and extract each octet by position, proving that an IP address is just 4 numbers separated by dots, and awk doesn't care about your subnet chart. It just splits on the period. Now the math lands in the shell. We'll let bash itself compute the usable host counts 4/24 and /16. 2 to the 8, minus 2, and 2 to the 16 minus 2. Watch the shell arithmetic flip textbook formulas into live numbers. 4/24, that gives us 254 usable hosts. 2 addresses are always reserved, the network address and the broadcast address. 4/16, we get 65,534 usable hosts across the entire Class B range. Finally, we'll resolve localhost, the simplest lookup in DNS, and confirm that 127.0.0, that one always points right back at ourselves, the loopback address that's been waiting for us at home this whole time. That's the full preview. 5 commands, 1 fun math trick, and 1 local resolution test. The terminal is open, the checklist is set, and the demo runs next. CIDR notation defines networks by a prefix length, but the real numbers, how many hosts fit, how octets split, only become clear at the command line. This walkthrough uses stock Linux tooling, IP, awk, and shell arithmetic to inspect and count addresses directly in the terminal. The IP command reports every active interface along with its IPv4 address and prefix. Running IP-4 address show piped through head reveals the loopback address 127.0.0.1/8 sitting on the load device, confirming that the entire 127.0.0.0/8 block is reserved for local communication. Routing tables tell you how the kernel decides where packets go. With IP-4 route show, the default route via 192.168.1.1 on F0 appears immediately, anchoring the host's place in its local subnet. Awk makes a perfect tool for dissecting dotted quad addresses. Feeding 192.168.1.0 into awk with F splits the string on every dot, letting you print each octet as a separate field, a clean foundation for any address arithmetic that follows. In A/24 network, the last 8 bits identify hosts, that's 2 to the 8th power or 256 total addresses. The shell handles that arithmetic natively. Echo $2**8 returns 256, and subtracting the 2 reserved addresses gives the usable count of 254. Scale that up to A/16, common in campus and corporate networks, and the address space explodes. 2 to the 16th equals 65536, and reserving network and broadcast leaves 65,534 usable hosts, all derivable from a single shell expression. The /8 prefix on the loopback interface is what makes 127.0.0.1 always resolve to the local machine. A quick getent host's localhost confirms it. The resolver returns 127.0.0.1 from the host's database, regardless of which interface addresses exist on the box.